Hi, today we're going to have a very short lesson over lesson 5.2, the exterior angle theorem. All right, so let's jump right into the definition. The exterior angle of a triangle. So whenever you have a triangle, we're just going to extend one of the side lengths out. And so technically it makes a linear pair with the angle that's inside of the triangle. So as you can see here, I can just redraw. You have a triangle, and it could be any side. You just extend the side length out, and then these two angles together make a linear pair. And so this one out here would be your exterior angle. Now the question is, how many exterior angles can there be with one triangle? Okay, so if I extend them out kind of like this picture over here does, there's 3, but is there only 3? Well, let's take in consideration, yes, this is a linear pair, this is a linear pair, and this is a linear pair. But if I were to extend this one out, isn't that way a linear pair as well? And if I were to extend this out, these two would make a linear pair. And if I extend this out, these two would make a linear pair. So technically, you could have 6 exterior angles. So let's just number 1, 2, 3, 4, 5, 6. Now, a lot of times people get confused and they say this is an exterior angle. And they're not. They're actually vertical with inside of the triangle, and they're not exterior. They don't follow the definition, which is that they have to make a linear pair with the angle of the triangle. So if there's ever a question, how many exterior angles? The answer is there's 6, number 6. All right, so Theorem 12 just says the exterior angle of a triangle. Well, it's the inequality theorem. So I usually don't call it the triangle inequality theorem. I just call it Theorem 12. Technically, either one would be okay, but for Canvas sake, I always just call it Theorem 12. The exterior angle of a triangle is greater than either remote interior angles. And this is pretty basic. We know that this angle here, now I'm going to tell you something that's going to come up later. This exterior angle is actually equal now to something that we call remote interiors. Now, the way that I used to remember this is like your TV remote, you use it because your TV's far away. The one that's makes a linear pair with, it's not far away, it's right next to it. So the other two that are further away, those are called your remote interiors. And later we're going to find out that if you add these two together, it actually equals this exterior. But this theorem says that you can take either one of these and this exterior is going to be greater. So for I can't just call this angle C. I need another letter. So I'm just going to put an F here. So angle DCF is greater than angle D. Up here, there's no confusion if I just call this angle D. And angle DCF is greater than angle A. Which you're going to say, yeah, of course it is, right? And it is. And again, why do we have these theorems? So we can reference them when we do problems and proofs. So that's the situation. Now, this one is kind of like leading into like what's headed later in the chapter. You can't really use the inequality theorem, but this is just, again, to get your mind wrapped around, and I'm going to erase the fact that's a 9-degree angle. These two exterior angles technically equal this one, right? So if you see a problem like this ever, that's what we need to do. X plus 31 is equal to 2x minus 8, and then you solve. You really don't have like a lot of algebraic problems for this. This is more, it's just angle names, and then you have to justify it. When you see problems like this one is algebraic, and you just have to use the theorem that's coming later. So we'll talk about it more again later. Very short and sweet. You're going to complete lesson 5.2, the online assignment. And there wasn't a quiz last time, but there is a quiz this time. So let me know if you have questions. Thanks.